Okay, this is the second session of Tekla courses on version 2025 with Majid. Okay, the last session was about the introduction to Tekla and the BIM. How is the main purpose of BIM, and why we use the BIM first, or why we go through the BIM service. Today we will introduce the interface of the program and how we are working with. Okay, let's have a general view over the course right now. Our course is designed on 7 sessions, 7 to 10 sessions maximum. The first session of our soft today is about the introduction of for the program. The introduction starts with the program interface and the save and load attributes and forming grids, forming views, snap comments. But we will not make any members today. We just start the members on the next session about expressing the member types and how we model every type of the member. Okay? Okay, good. The first, when we open the program first, it comes up to an interface to choose the environment and the role of what we need to do. For example, if we have here several types of environment, each environment contains separate catalog for the profiles, for the connections, for the setup for the program. The steel profiles is not the same across the whole world. Many people don't do that. For example, if you are working in an environment for the US, you will find that they haven't got an IPE, HEA, HEB as in the Europe. They are dealing with they are dealing with W section, S section, M section. So they are telling, and even they're writing the profile in a different way. They are writing the profile in a W13 times 36, for example, W12 times 36, which means that the height of the profile is 12 inch and it's 36 pounds per feet. So this is the way they are writing it. The English, for example, or the UK writes the profiles in a different way. Same as we did here in Australia, actually. They're using UB, which means universal beam, UC, universal column, and usually they write the dimensions of the profile. For example, UB 275 times 73 times. You'll find 3 or 4 numbers for the dimension of the profile. The Europe catalog is completely different because it's just have some types of the IB, which depends on the ratio between the flanges and the web. For example, the IPE, we have the ratio is the flange is half the width. Tell IPE 300, I think. 300, that means that IPE 300, we have got a width size of a 300 mil and a flange size of approximate 150 mil.
What about the Middle East?
Middle East, we are using a combined sections. If you use the Middle East profile, you will find a lot of sections. Some of them are Europe, some of them are English, some of them are US. It depends, because usually Middle East is not fabricating steel much. They are importing steel from several places. Okay, so it's important to identify which environment you will work with previously. Of course, if you are working here in Australia, the main idea is the Australian environment. If you are working with the Middle East, you will open always the Middle East environment. If you are working for a US company or something like this, you will work with the US environment and so on.
Yep.
The other thing is the role. It doesn't matter a lot to have a role for a designer or a contractor or engineering or any other discipline. Usually we use the role of all. Previously, that was the configuration for the license was different. For example, you will have a drafter license, an engineering license, and so on. Now you have the license have been completely changed in the new design, so it will be a standard diamond carbon and so on. After that, we'll press OK. Now we will start to introduce to a new part of the interface. The first interface is just to check which part of the world you will work in. The second one will have the recent model you have opened and the shared model you are in, if someone shared the model with you. So you can here connect to the Trimble Connect and check the shared model through the shared model folder. Tekla have got an opportunity to have more person working in the same model, and it doesn't mean that these persons should be located at the same place. You can work through the internet, so someone can work with you from Egypt, someone can work from you from South Asia. It doesn't matter, as you are connected to the internet and to the Trimble Connect. So now this model, for example, is created in another place. It's created in another device. But you can reach it if I decided to open it. I just move it and call join. It will go on and start it. Okay. Otherwise,
It's another device. But
yeah, the company device actually.
yes, because I could read the name of the product.
Yeah, that's true. That's true. It's not created here, but you can start it here also as well, because just they are linked on the same on the internet.
Yeah. So you can work from home, for example.
Yep, sure. And in your laptop, in your private laptop, in another machine, it doesn't matter. It doesn't matter. The license not matter if it's on the same device or not.
Yeah.
If the model is shared through Trimble Connect from the start of the process.
Mm-hmm.
Okay. Reopen it again. Yep. Australia, and now we'll not go for the join as a join of this model from the internet. We'll have a new model by your name as a testing model. So we will not use a share model. We'll use a new model. Of course, all model is to open a model from a certain place. You can open a model from a certain place. Now we can make a new model. This new model, you are choosing the path of the model. For example, we'll get it through not the sources. We shall get it through the e-learning. Okay. And this is the courses, Tekla courses. And this is measured course. So we'll create in this folder our Tekla model, and we'll say it's measured model. Okay. Create. Easy?
Yes.
Are you sure? Good. That's perfect. When the model is created, it's not like an AutoCAD file, it's single file. No, it creates a big folder and contains many things, many subfolders and many files, including group files that's used, including materials that's used, including attributes, including the building geometry and shapes. So in Tekla, the project is not a single file as in AutoCAD. It should be open through the program and it contains a lot of files. They are all forming the library of the same file, but they are not a single text file as in AutoCAD or in Excel or in Word or any other program. The first thing when we open the program, we catch is this cube. This cube is the working area that we are working on. Suppose we are working in a big mold like what we did here. This big mold, for example, I'm working right now on the stair area. So I need to specify only the stair area. That's the specification of a certain area that I'm working on. Other than this area, it's not shown.
Yes.
We'll discuss this later. And the second thing is the red lines. And finally, we can here see the UCS or user coordinate system, which is X, Y, and Z, and the global X, Y, and Z, which is coincide to each other always. Okay? Anyway, the general concept in Tekla, if you need to modify anything, just double click on it. It's a very simple thing. For example, if I need to modify the view here, I just double click on the view and we'll get the view reference. Okay? What you need to modify it. For example, I need to change the view from a 3D point to a plane point. Now let's change it to a plane point. I need it to be a 3D again. So anything the same here with the grid. If you double click on the grid, you will find the grid properties is coming up here in the right side of the screen. Okay. So as a general, if we need to modify anything, we have to double click it. Is it easy?
Yep.
This is the first concept of the work. The second concept is that we have here a concept of saving and loading this attribute. Before going to the saving and loading attribute, let's discuss something. Why we are putting double click. The first click is for selection. The second click is that you mean that I need to modify this one. For the selection, to show the selection, for example, for the view, the first click, you will see that there will be a yellow or orange frame around the screen. See, if I select the red line here, this orange frame is disappeared. That's because now I'm selecting new items. And instead of that, I'll see that the grid line is highlighted.
Yep.
If I click here, that means that I'm selecting the frame now, the space. It's important for that because if I double click for the grid line and I by mistake select the screen, it's not shown here. Sometimes, for example, you can select a beam column, for example, this beam column, and you select a beam and just press modify. It's not modified here. That's because you are applying a column properties into a beam properties.
Yeah.
And sometimes you are applying, for example, this is a view property and you're selecting this grid line and you are modifying this plane. Modify, it will never modify.
Yeah.
Actually, why it's not modified? Because you're not selecting the screen.
Yeah.
You're trying to apply a different properties which is supplied for the view on a different property which is the grid.
Yeah.
Which cannot be. Okay. In the same time, we have a general concept here for save and load attributes. What's save and load attributes? Let's discuss something. Assume we are sitting here in this cafeteria. This is a good restaurant, and we have a setup here. Okay, we tell the waiter that when you find us coming up, please set up the setting as it is now. Majid will be on my left side, and I'm sitting here. Prepare for the source of electricity for the laptop, and prepare a quiet area. So this setting is saved in the waiter's mind, right?
Yeah.
If I need to get it back, I just go to the waiter and tell him, please get me the setting that I told you about before, right? That's the attribute. That's the means of the attribute. But actually, if I decided later to change that setting, for example, I'd say to Majid, please, could we replace our places? Okay, waiter doesn't see that. Does this changes anything in the attribute? No, right? That means that the attribute is used only to set up the beam or the column or whatever you want. It's just a setup, a startup. But it will not have no effect other than this after the object is created. You can modify its length, its color, its profile, its everything. You can modify its characteristics without affecting the attributes. In the same time, if you have updated the setting for the attributes, it will never affect the member or the object that you have created inside Tekla. So it's very important to know that saving and loading attribute is a helping tool to help up you setting up quickly for the members you are currently have to do, but not affecting anything right now or future. Let's see this. First, how to save and load attribute. For example, I'll load here. I'll change the name to be main 3D, and just save it as main 3D. Just save as here. That means that it will be loaded here. Okay, let's check, for example, if I need a plan view and make load. Now I'm telling the widget to get the setting that's saved here. Now if I press modify, see, the view plan have been changed to plan at RL, and the view is changed to plan as well. So it's all converted to the new setting. If I need a new setting as well, I'll do the same. I'll just get up the setting for main 3D and would say it's load. Now I can get my view again, right? So the second concept, so let's refresh now. The first concept is that if you need to modify anything, just double click on it. The second concept is that you can make use of a saved settings or saved attributes for everything in Tekla, including beams, columns, red lines, plates, whatever you want, whatever object in Tekla, you can use the save and load attribute with the properties you are caring about. Is it clear? Good. Let's now transfer to another place, which is the view properties itself. You'll find that any window in Tekla have got a certain specification. It gathers all the informations in one box. For example, here you can see that there is a box for the view that contains the properties of the view. Another box is for the presentation for the members, which allows you to control the color, the transparency, and such things inside the model view. And the third box is for the visibility, what's to be seen in the view and what's to be hidden in the view, and how we can deal with the how much depth the view is. Let's now concern with the first box, which is the view itself. The first thing is the view is the main 3D of the view. Okay, that's the name of the view. You can name the view whatever you want, as you wish. Once you are telling modify, it will be modified. Okay, Ahmed, we have three bottoms here, which is modify, apply, okay. Why are you choosing modify? Why you are not choosing apply? Apply is more reliable, right? Apply means to apply it now. Actually, no. Modify is to modify the current setting. Okay, that means if I did modify here, it will modify the current setting for the view. But if I load this plan view, for example, load, and instead of pressing modify, I press apply, you'll find nothing have changed. Okay, what's apply is for? Apply is for apply for future setting. When I make, for example, when I make a new view, create a new view, basic view, for example, it will take the same view of plan at RL, and it will take the same properties here that I'm used. So apply is always apply for future setting. If I need this, for example, this view, I can get the current setting of the view. So I have get, modify, apply, and okay. Get is to get the current setting for a member of an object or anything in the Tekla. Modify is to modify the current situation as per the modified properties. And apply is apply for future settings for these properties. Whatever it was, a beam, a column, a view, a grid line, an object, whatever it was. Okay. Of course, you have two bottoms here, which is okay to close the window, and also you can choose the close the window by canceling this. Okay. Both bottoms are doing the same thing. Is there something anymore? Okay, as the people is going normal, it's okay for us. Okay. So the first thing is the name. The second thing is the angle that you are seeing the view of. Whether it's a 3D or a plan. You can choose whether to use it as a plan or as a 3D. The same thing we are using, the same thing with a Control plus P for pen button. If you are using the same button, Control plus P or pen, you can switch between the two forms of the 3D and plan as well. Okay? Is that clear?
Yep.
So we have a Control button plus P for pen or P for plan as usual. Okay? Okay, that's good. The second thing is the rotation around Z and around X to give this isometric view for the view. For example, if I did it as -30 and 60, modify, you will find that the rotation have been modified, right?
Yep.
Actually, this is also can be modified easily by pressing the Control button and the scroll of the mouse and start moving around the model. You can change it whatever you want. Is it clear?
Yep.
Okay, that's good. That's perfect. For example, you can get it here, the current rotations. Okay, good. The last thing in the view properties is the projection. What's the projection? In our work, we have two types of projection, which is perspective and orthogonal. What's the difference between a perspective preview and orthogonal preview? The perspective review is something like an architect perspective. That means, for example, if I'm looking towards a hole, I'll see the near columns is so wide, and I'll see the far columns is so narrow, getting up to escape point. That's how the perspective is working on. But actually, during our engineering process, because we are not an architect, we are mostly detailer, that we are aiming to get more precise of the buildings. We need to see the whole columns in one line. The first one is solid and the other one should be dotted as it behind the column. So in that way, we are always using an orthogonal view. We don't use perspective view normally, okay? Unless we are making a 3D presentation or something like this, you can allow to get it as a perspective. No worries, okay? Okay. The second thing for the presentation, we haven't got any members yet, so we cannot test how the presentation will be in that values. Okay. The last thing is the visibility. What is be seen in the view and what not to be seen in the view. For example, the first thing is the view depth. What's the view depth of a view? Let's consider that we have here a plane. This plane is just a guiding plane around the corner here, around the plane for this table. What's the view depth up? That means that what things can I do up to this table?
Yep.
And what things can I see down this table? As an example, for a famous case, if we are working with a mezzanine floor and we have got a bracing below this mezzanine floor,
Yep.
or a roof, for example, and we are working in a bracing on it, the bracing is usually placed down than the beams, the second beams. If I set a view depth is lower than this, I wouldn't see the bracing. To see the bracing, I must set up a view depth greater than the whole beam, so I can see the whole bracings. So what we can see is a slice in the building. The view depth is resembling as a slice in the building. Okay, what can I see up and what can I see down the view depth? Okay, is that clear? The last thing is for the visibility of objects. What type should be object seen in the view? For example, as spots, points, and so on. As we haven't got much things done yet in the model, we will discuss it later once we have more items in the view. Okay? Now, is everything clear in that view and program interface?
Yeah.
Let's have here the a somehow rule actually for that. This rule is I need to clear something. Okay. Okay, I need to draw something here. What draw? Where is draw? Comment. Oh yeah, I need a comment. Yes. I need using drawing tools. No.
Nope.
I need to mark this tool and save and load attribute as well.
Yeah, they're done.
Now, excuse me?
You mean that they're done?
Yeah, that's done. Okay, that's to know how far we are coming up in each session actually. Now we are coming to the forming grids. The grids in Tekla is very easy thing. Just as I told you before, we have to double click on the grid to get the properties of the grid here. Okay. For the properties of the grid, we have a grid in X, Y, and Z. Let's have a plan by Control plus P. P for plan, and see the changes that we are doing here changes exactly in the meantime. For example, in X direction, which is in this direction, we can have, for example, a grid line at 0, which is the main grid line here. It's called A. So we'll have grid line at 0 and a grid line at 6,000, grid line another 6,000, grid line another 6,500 and 6,000 and 6,000. Now you can see that the grid line have been modified 2 times 6,000 and then 6,500 and 6,000. If you can change this also to 0, it will be 5 times 6,000. You can write this either in the same way I did before, or you can write it directly 4 times 6,000. It will be the same issue. And you can have here 6 times 6,000, for example. It will be the same as well. Okay? Same will be in the y-axis, for example. Y-axis will be 5,000. 5 times 4 grid lines times 5. You can see here that the working plan or the working cube is not filling the whole area of the working plan. To fit the whole area in the working plan, you should select first the view, then right click on it, and you will have a choice to have a fit to work entire area to entire model. It will expand it already to cover all the internal model area. Is it clear? Good. Now, we can have here, so we knew now how to adjust coordinates in X direction and in Y direction. The last thing is to adjust in Z direction. You can see that in X direction and in Y direction, it's not an accumulative dimension. That means that I need 6 grid lines with a spacing 6,000. So it will create a 6 meter apart. Each grid line 6 meter apart. It's easy, right? For Z, no, it's not working like that. It's working as an accumulative. So I'll have a grid line at 0, which means that the level here is 0. Then I work out at level of 5,000. The next level, I'll have to get a space. The next level, if it's a space just 4 meter, it will be a 9,000. It will not be a 4,000.
From 0.
Yes, exactly. So I'll have here a 9,000 meter. and a finally space and 10,000. Okay. By this way, we'll have an accumulative grid lines. I can see these grid lines here, but you can use it easily. Control plus P. If we get a new view by 2 points, for example, to see the grid lines here. See?
So the line here.
Yeah. Now it's 0 to 5,000 and to 10,000. It should be 9,000. Yeah. Because it's not reading well. Let's have a measurement here. We can go to edit and start measure from 0 to 5,000, 5,000, and to 9,000, which is 10,000 here, but it's not correct. It's a 4,000, and from 9 to 10, it's only 1,000.
Why you didn't give that?
Because the naming. The other thing is the naming. We haven't named it in a proper way yet. Okay, we'll start with the naming them. For example, we will say that RL plus 0.000. This is the level 0, and then RL 5.000. Sorry, plus. Yes, elevation. And RL plus 9.000. Space RL plus 10.000. If I say modify, now it's modified. Easy? Okay. In the same way, we are getting here to the plane. We can name, for example, this is A, B, C, D, and this is 1, 2, 3. Okay, let's start this. Well, for example, we say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so on. And let's make modify. What we can note here, first I missed a space between 1 and 2. So the first grid line was read as 12. If I need to 1, 2, I just need to be a space between them. Okay? Now it's 1, 2, 3, 4, 5, 6, 7, and stop there. Okay, but I have filled till 14.
Because this.
Yep. It will never get you a warning about this. Okay? So if you name more than labels, more than inside here, it will never warn you about you are doing the wrong thing. That's very important for you to take care about when you are getting up the grid, especially in big projects. For example, I've worked in a project that have got about 80 grid lines. Yes, it was about 400 meter length and 800 meter length and 400 meter width, which was a big mall, a big massive mall actually, and I need the full grid line. So I had to get a lot of grid lines inside the mall and working them separately. If I have been failing in one grid line, it would be a disaster in the other, and I wouldn't recognize. In the same time here,
If you write like you wrote more numbers.
if I wrote less,
Yeah.
right? A,
No, it's alright if you write more. But not right if you write.
No.
Let's.
also the same. It will not give you anything. See? It names A,
Yeah.
B, and the rest is clear.
I mean, what about if you write more? There's no problem.
Yep.
If you
Yeah,
write less, there's a problem.
there is a problem, but it will be shown grid lines without any labels. So you must make sure that you are labeling all your lines in a correct way. Okay? Good. So now we have made, as in Tekla, as we told you before, we have an each part is separated with a box. You can have here, this is a coordinates. This is the labels. So you can show whatever you want, and each part is represented or responsible for a certain property. Is it clear? Okay, good. The second thing that we are doing is the label or the extension of the lines. Okay, what's the extension of the lines here? See this intersection between the grid lines? That's the line intersection. Here it's stated is 2000. If you need more extension, you can have more extension. But usually, no one is needs more than 2,002 meters to be extended for the grid lines. Okay, and this is left and below and right and above. Okay, good. The origin of a grid line is very important. For example, you have worked in the tunnel before, right? What if we have got a structure inside the tunnel?
Yeah.
And this structure needed to be located with an X and Y direction according to the east and north.
Yep.
You can easily move the grid line through this origin. Okay? You can move this grid line. That means that I am starting here from 0, but please make sure that my building is at east so and north so and above the sea level Z by this value. So you can change the orientation or origin of the grid line as well. In the same time, we have got an option here which is a magnetic grid line. What's magnetic grid line and what's it used for? An easy way to express this, we can make a fast beam here. For example, this beam here and this beam here, and make their colors as a red color to be shown. Good. Now, we'll select the grid line and make it magnetic. And press OK. Modify. You can see that the start of the beam here is in grid B, and the end is in grid E, and it's located along grid 2. What if I use this to be a 6,000 instead of 5,000? The beam will be extended with the grid line, because each grid line here is a magnetic grid line. It attaches all the points located in the same grid line. And we can see here, for example, if I change this 6,000 to 8,000. Sorry. Until they modify, you will find that the beams is relocated on the grid line as well. So a magnetic grid line is attaching the whole attached points to each place. In case you have modified the grid line, it will be shrink or attach it to the grid line. Okay, that's a good thing. So if I have got a building, I can use these magnetic grid lines to go through and in through the building. For example, as in precast, we are getting walls here. If I need a small building, I would shrink the grid with a magnetic grid. It will be fantastic, right?
Yep.
No, that's not right. Why is that? Because some of the panels is not located in a grid actually. It will be located in between the grids.
Yeah.
Yes. So it will be shrink from the start and the end, but in the intermediate it will be crashed to each other or clash to each other.
Yep.
So it's important to use the magnetic grid line. If you decided to use it with a big thinking before and checking after it. Clear?
Yeah.
Well, that's all about the grid and creation of grid views and creation of grid in Tekla. The last thing is to say about grid lines is that the grid line is acting in Tekla as an object. You can copy this grid line, for example. You can use a copy order to copy it from a place to a place. Okay? In the same time, you can rotate it. Let's start, for example, move, special, rotate, and you are selecting here by a 45 degree. It will be moved here as a 45 degrees. So, grid lines in Tekla can be moved, can be copied, can be rotated, can be deleted even. No worries. Okay? It will be acted as a typical plot in Tekla structure. Is it clear? Any other questions for the previous discussion?
Yeah, what's
Are you sure? Hope that. Okay. Now we can mark the grid forming grid lines. Good. Now we are coming up to forming views. Forming views in Tekla is very easy actually. First of all, we can use several types of forming views. The first type is to use a basic view. I can choose in the basic view the plan of the view that's coming up, whether it's an XY plan, XZ plan, or YZ plan. For example, if I need to get a plan here is not meaning that it's always horizontal. A plan means is that it will be perpendicular to a certain place. For example, if I need a plan on grid line 2, which means an elevation actually, and across grid line 2. So I'll choose here the plane to be parallel to YZ. So I'll get here a basic plan across YZ here with a space of 6,000. Right? And we'll create this plan. It will be created here. This is the basic view. Yep, okay, thank you.
Huh? You still have it? I'll put your hand down. Sorry.
Okay. The same thing I can do here for grid line and grid line B, for example, which will be parallel to grid line XZ. So I'll get a new view, basic view about XZ, and this time is 5,000 space. So I'll create a new view across grid line B. Is it clear? Okay. Okay, that's good. So that's a simple thing to create a basic view. On the other hand, I can make a more better solution. I can use 2 points to create my view actually. So I can create the view on D by this way. It will be appear that the direction of view according to the direction of arrows as well. If I do it like this, I can get the view more faster. Right? Good. And I can create also a view using 2 lines which can be inclined. It's this view. You can see here the inclination. You can see a grid line A and 1, grid line D, grid line 2, because it cuts. Well, yeah, it's shaping the building by a corner thing. Okay, a corner cut. Okay, that's good. And I can create another view using 3 points if I have an inclined plane. Okay?
Yep.
But the most thing, I can do it easily by selecting the grid lines here and simply create views along grid lines. It will be easily to create whatever view I need. I just create all views in XY plane, all views in ZY plane, all views in XZ plane. An initial plane, for example YZ, I'll name it prefix as a plane. In YZ, elevation grid, and XZ as an elevation grid. Also, I can choose the correct attribute that I have been set before to be used here with a view depth, for example 200, 500, whatever it was, no worries. Okay? Just click OK. The views is created. Sorry. Just press create. Now the views is already created here. I can check the view here, red television 1, 3, 4, B, A, and planes as well. Oh. You are allowed to open only 9 views, not more than this. 9 views only. Okay? I don't know why. Just you are not allowed to open more than 9 views in Tekla structure. So, by this way, you must clear some views. Okay? Okay, that's good. Now, I can choose my main 3D view. And for example, I can choose 1 and A. Now, the views is full. How can I get another view from now? I can use to replace the view. You could use the shortcut of Control plus Tab to get different views. Okay.
Yeah.
So, is it easy to create a view? Easy to replace the view, and you can easily open the view list whatever you want and create the views whatever you want.
Yeah.
Okay? Is it easy till now? Have you got any questions about this?
No.
Are you sure? Okay, that's good. Now, we're coming to the last part in our session, which is the snap commands.
Yep.
The snap commands is similar to that on AutoCAD. It's a snap of end, intermediate, cross-section, perpendicular, and whatever you want. In spite of that, we have here special characters that you can specify a symbol or an exact snapping. For example, if I made here a steel beam, and starting this steel beam, I need it to be from the midline, from the midpoint here. I can just right click here and state it that I need the steel beam from the midpoint and just point to the grid line. It will be catch automatically the midpoint only. I need this steel beam to be perpendicular to that. I'll just right click and choose the perpendicular and it will be drawn perpendicular to the line.
Yeah. What if you took the mouse to the right?
It will never do this. Let's try it again.
The other.
Let's try. For example, this from the midpoint and perpendicular, and I'll stay with the mouse here. See? It will only catch the perpendicular.
What if you do it here in the middle? You put it over the grid line or below?
Doesn't matter. See? It will always catch the perpendicular as I'm only using the perpendicular. If you need it, I'll just remove the perpendicular here. Now you can use it with several times, with several places. Okay? So you can choose the current setting for the snap. Otherwise, you can choose what snap you need. For example, I need it to be in the intersection, so it's only points to the intersection. Okay? I have also something else. I can use the ortho, which is an O. You can see that the O letter is appearing here at this spot. This means that the ortho is switched on. For example, here, if I make the beam here from that point, I can get it with a perpendicular.
Only perpendicular.
Yeah, 45 and perpendicular.
And you get
Okay, so you can get it. See,
what?
45 and 90 as well. I can have the choice this through ortho. If I switch to the ortho option in the grid lines. Okay, in the snap commands. The last thing is that if I see, for example, this one, I'll teach you later how to control the presentations. For example, if I need a beam here and I want to draw this beam, I have two options here. The first one is to select the reference lines, which means the start and the end of the beam. If I select this beam, I see a yellow point which is at start and a magenta point which is at end. So by making the selection through this line, that means that it will be only on the reference point. See? It will not catch anything except the reference point. If I move here, it will not catch anything except the reference point. To catch the small points, I have to make it to the geometry lines. But this way you can catch the edge. See?
Yep.
But there is another thing here. For example, if this I catch a snapping for this edge, you will see that the snap point is small. Otherwise, I'm pointing to the reference line. It's big. See? Small one, big one. Small one, big one. Right? So by making so for snapping option, it will allow you not to snap on negative on the wrong thing. not to snap on the wick, for example, or on the edge by wrong thing. If you just watch up the snapping symbol for that. Is it clear? Okay, that's good. Ending the session of today by a question for discussion, and we will check it. What the types of members do you think is in the structures?
Members.
Yep.
Beam.
Beams, columns, slabs. Good. What else? Footings. That's good.
So many other members. Beams.
Bracings, for example. Yeah, good. So we have here different types of member. Tekla have been categorized the members in three main categories. Okay, which are the
Column,
first
beam.
type? Yeah,
Right.
column, beam, and plate. What's the difference between column, beam, and plate? And why we choose the three columns of these three categories only? I'll tell you. If you are discussing on a drawing, for example, I'd say that we have a problem for the column between grid line A and 2, for example. Now, I specified only one point, which is the intersection between grid line 1 and 8, right? So, specifying a column is always one by one point. You don't need another point to say that the column is vertical, right?
Yeah.
The column is always vertical. So, when I'm telling about the column, it's specified always by one point. On the other hand, this point can have four beams in the same line. So, if I told you the beam that is between grid line A and 2, say, yeah, that's the first point. What's the second point? I'll tell you the second point in grid A and 3. Then you know that the beam have got 2 points as well.
Yeah.
So, always columns is described with one point only. But beams is always described with 2 points. And at the third category, which is the plates and slabs and any other categories, can be specified by 3 points and more. Yes, it's a slab, it's a surface.
Yep.
So you can identify a surface by 3 points and more because it's identified by a plane. Other than this, it's a beam or a column. So a bracing in Tekla is a beam. Anything that can be expressed in 2 points is a beam. Anything that can be expressed in 1 point is a column. Anything that can be expressed by 3 points or more can be a slab or something else that we will know later, which is volley beam or a beam that will be aligned with several points, but it's not a surface.
Foundations, for example,
Foundations can be, if it's a raft, for example, it will be acting as a slab.
as a plate.
As a plate, slab, exactly. If it was a single, it will be act as a beam, like a strip footing, for example. If it's a column, if it's a foundation bed, yes, bed concrete.
Strip footing.
A strip footing is a beam, yes, exactly. So that's the main specimen. Yes, exactly, as tie beams example. So we have 3 categories of members also. One is specified by a single point as column, one to specify using 2 points as beam, one was specified with surface by 3 points, which is slabs, foundations, and everything else, or plates or beam. Is it clear for today?
Very simple.
Are you sure? I feel I press you too much.
Very good.
Good, that's good. Thank you for that. Let's end for this today. We have been almost 1 hour.